Welcome back to Aurora Tech Channel. Today, I will review the Sovol SV06 Ace. It falls into the mid-range budget category, one of the most competitive parts of today's 3D printer market. Let's dive into the details and see what this machine has to offer. The print volume is a standard Ender 3 220 by 220 by 250 millimeters. The motion system uses steel wheels on the X and Y axis and thicker 10mm linear rods on the Z axis. There are two independent stepper drivers to control the motors, allowing for the gantry to level automatically. On the Y axis, it uses the higher torque NEMA 17 47mm stepper motor, while the X and Z axis use 35mm and 40mm motors. The belt on the Y-axis is also using a thicker 10mm belt compared to the standard 6mm one on the X-axis. The extruder is a planetary dual-gear extruder, similar to other new generation Sovol printers. The hot end is a high-flow hot end with a ceramic heater. The part cooling fan is a turbo blower, and it doesn't come with any auxiliary fans. The maximum nozzle temperature is 300 degrees Celsius, and it is pre-installed with a brass nozzle and comes with a spare one. The bed leveling uses a pressure sensor placed inside the print head. It uses the nozzle to probe the bed, and the Z offset is set automatically. The maximum bed temperature is 100 degrees Celsius. It uses a double-sided textured PEI spring steel sheet, and there's a silicone pad at the end for nozzle cleaning. The claimed top speed is 600 milliliters per second with a 20K acceleration. The power supply is 360 watts, and the motherboard is a Clipper motherboard that runs a quad-core processor with 512 megabytes of memory and 8 gigabytes of eMMC. It uses an open Linux system and open source Clipper firmware, so it works just like a computer, and you can do whatever you want on this system. It uses Orca Slicer, so you can send prints over your local Wi-Fi network directly from the slicer. You can also use the Alpaka app to remotely start a job outside your network and monitor the print. It will send you a notification when the print is done, or it will stop it automatically when it detects failure. For other features, it uses the 4.3-inch capacitive touchscreen. It comes with a filament sensor, belt tensioners on both the X and Y axis, a camera, and a small LED light. So overall, this SV06 Ace is clearly packed with a lot of features. I would like to thank Sovol for sending us this machine and for sponsoring today's video. Even though this is a sponsored video, we will provide an unbiased review and we will not hesitate to point out any cons. With that said, let's get started. The machine came in a compact box. All parts are well protected by laser cut foam. The structure of the machine is simple. We have the gantry, the power supply, the touchscreen, spool holder, the base, the motherboard enclosure, the print head, and the power cord. Like any bed slinger, we will connect the gantry to the base, then mount the motherboard enclosure at the back of the gantry. The screen is mounted at the front right. Then mount the camera module on the right side of the gantry and secure the print head to the X carriage. The spool holder is mounted at the top. After that, we can connect the cables, including the filament sensor, the power supply, stepper motor, and screen, as well as the stepper motor on the other side. Followed by the cable from the camera enclosure, check the power supply to match your local voltage, then we can turn on the machine. Select language, connect to your Wi-Fi network, and then it will start a self-test, which includes all the X, Y, and Z axes, the heaters, fans, input shaper, gantry leveling, and finally a 5x5 25-point bed leveling. We can now use the screen menu to load some filament. I will start with the preloaded G-code, the 13-minute fast Benchy. It starts with cleaning the nozzle, then it'll do a small area bed leveling that matches the size of the print. After the first two layers are done, we can hear the part cooling fan is working at full speed. Let's check the sound level. The sound meter is about 6 inches away, and the sound level is around 60 decibels. No matter if there are rapid movements or not, the sound level stays the same. So the loudest sound is the part cooling fan. print finishes in a little less than 13 minutes. The layer lines are pretty obvious, as it was printed at a 0.25mm layer height. The bottom looks fine, and the cooling at the front is alright. There's no under extrusion from the top. As a Benchy printing that fast on a bed slinger, the result seems not bad. Let's print another normal speed Benchy at a 0.2mm layer height and compare the results. When printing at a normal speed, the sound is about 3 decibels quieter, but when the part cooling fan is at full power, it still goes up to around 60 decibels, so the difference is not too obvious. The print finishes in 33 minutes and 17 seconds. Let's compare the result. The 33-minute one is printed at a 0.2mm layer height, and the layer lines and surface quality are both better. The cooling on those overhanging areas are also better. At the front, we can also see the cooling is better, and from the back, the details, the cooling, as well as the surface quality are all better. Next, I will do my benchmark test prints, starting with the number slider. I can see the auto-Z offset is a bit too low, and the first layer may be squeezed too low and affect the clearance, but I will just let it finish as I want to see how it prints right out of the box. The print finishes in 2 hours and 31 minutes. The print speed is about 15 minutes faster than other bed slingers, and it's in line with Core XY machines. The top is fine with just a tiny bit of stringing, which is normal for this model. But the back was not printed too well. Some tiles are connected with each other as the first layer was squeezed too low. I will manually move the first layer up 0.05mm and print it again. This time, the first layer looks perfect. The top of both models look the same, and they both have a tiny bit of stringing. The bottom of the second one is better, as some tiles on the first one are connected to each other. When I try to move the tiles, the first one was not smooth. I need to snap and break the first layer in order to make it functional, but for the second one, all tiles can move freely. Then, I will print the mini honeycomb box to test the retraction. It seems the extruder handles retraction pretty well on this tough model. The print finishes in 2 hours and 34 minutes, which is in line with other clipper machines. The print finishes pretty well, and all honeycomb patterns were printed successfully without being broken. When zooming in close, we can see some stringing. Let's compare the print with other machines. Here are the models that were printed the best so far by different machines, including the BambuLab A1, the X1 Carbon, the QiDi Plus 4, the Creality K2 Plus, and the Prusa Mark IV. The results aren't too far from each other, but when we compare it to the machine in the same price range, the BambuLab A1, the SV06 Ace is slightly cleaner. Next, I will print the tolerance test to see if the parts can fit together. The print took 1 hour and 19 minutes to finish. On the square side, it can clear up to 0.05 millimeters and get stuck at zero clearance. On the cylinder side, it can also clear up to 0.05 millimeters and get stuck at zero clearance, which are both perfect results for both sides. Then, I will print the Robo Alpaka to test the surface quality. The print took 4 hours to finish, which is faster than the average 4.5-hour printing time. Let's take a look from all 4 angles. We will also compare it with other machines. All machines are using their default 0.2mm profile in the slicer to print the exact same model. Compared to the BambuLab A1, the SV06 Ace is much faster, while providing a similar surface quality to the A1's 5-hour 37-minute print. When compared to the Prusa Mark IV S with the input shaper profile, the SV06 Ace is not only faster, but also produces better surface quality. Against the Ender 3v3, the SV06 Ace is also faster, but also produces better surface quality. Even when compared to the Core XY K1C, the SV06 Ace keeps its speed advantage while providing a similar surface quality, which is really impressive from a non-Core XY machine. When compared to the Creality K2 Plus, which I tested last week, the K2 Plus is the fastest of all the machines I've tested, and its surface quality is also on par with the SV06 Ace. Lastly, compared to the QiDi Plus 4, which holds the highest surface quality rating on my recommendation list, the SV06 Ace is about 45 minutes faster. But in this case, the QiDi Plus 4 is better than the SV06 Ace in terms of surface quality. Next, I will print a PLA sheet to test the bed leveling and the auto Z offset. Keeping in mind that I previously moved up the Z offset 0.05 millimeters and saved it permanently in the firmware. The print took 40 minutes to finish, and the PLA sheet can peel off in one piece without line separation. The top looks fine, I can't see any noticeable imperfections, and the bottom looks perfect. I will try some other materials starting with PETG. This pen holder took 2 hours and 32 minutes to finish. It's pretty fast for PETG, the surface looks fine, and there's no stringing inside. The bottom also stuck perfectly, so this is a beautiful print. Up next, I will print a TPU tire. This print is small, and it only took 26 minutes to finish, even though the default slicer profile set the volumetric speed to 3.6 mm3 per second, which is just around 40 mm per second in speed. The surface is pretty clean and there's no stringing. The inside is almost no stringing. As the maximum nozzle temperature can reach up to 300 degrees Celsius, but the printer didn't come with any hardened steel nozzles by default, I will try to print some polycarbonate. I put glue on the bed, as I don't want the PC filament to stick too well, which could damage the bed, so the glue will just work as a release agent. The print finishes in 40 minutes. The surface quality is good, almost as good as PLA. The holes are also printed nicely with minimal cooling. I can't see any issues on this print, and it's a perfectly functional part. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The motion system has been upgraded to use steel wheels and thick 10mm linear rods. Compared to the palm wheels used on the SV07, this motion system is more capable of printing at high speeds. 2. The print speed is fast. It's on par with Core XY printers, and both the surface quality and accuracy are still good, if the Z offset is adjusted correctly. 3. Cooling is strong. Even though there's only one part cooling fan on the print head, the cooling is on par with other machines with an auxiliary fan or even 2 auxiliary fans. 4. The UI of the SV06 Ace is clean and highly functional. It comes with built-in Obigo integration, allowing users to link the printer to the Obigo by simply scanning a QR code. This feature provides seamless control and monitoring of the printer through the pre-installed camera. With the Obigo app, you can manage the printer remotely, even when not connected to your local network. Additionally, the app sends you notifications when prints are finished, or they pause them due to detected failures. 5. It uses Orca Slicer, so you can just send the print over your local Wi-Fi network. The mainsail web interface can be accessed within the slicer. The uploading speed is also faster than Prusa and BambuLab ESP Wi-Fi modules. 6. It runs on a fully open Linux system, giving you complete flexibility to customize the machine as you see fit. You can install any programs and run your own scripts without restrictions. Now for the cons. 1. The default Z offset on the SV06 Ace is slightly too low. While this won't noticeably impact most prints, it can affect the precision on some tests like the number slider and tolerance benchmarks. You can use the screen menu to temporarily adjust the Z offset, but caution is needed with the 0.5mm adjustment button. Lowering the Z offset by that much can cause the nozzle to grind into the bed and cause damage. I believe the 0.5mm option should be removed from the menu, as increments of 0.01mm, 0.025mm, and 0.1mm are more than enough for fine-tuning. Moreover, the adjustment on the screen is only temporary and will reset after the printer is powered off. For a permanent adjustment, you need to manually edit the clipper.cfg file. 2. The screen UI is clean, but it's missing some basic features. When the print is done, it doesn't show the print time. The file page is not sorted by upload time or by alphabetical order. This becomes an issue when you have a huge number of files, as it can be hard to find the one you need quickly. 3. The estimated time provided by the slicer profile is not entirely accurate. Generally, the actual printing time is 10 to 15% longer than the estimate. For single layer and smaller prints, the estimates are pretty accurate. This suggests that the firmware's acceleration settings aren't aligned with the slicer's calculations. Nevertheless, the speed is still faster than most other clipper bed slingers and most Core XY machines. 4. This printer uses non-standard nozzles. By default, the machine came with one brass nozzle pre-installed and a spare one. Even though the maximum nozzle temperature can reach 300 degrees Celsius, it didn't come with any hardened steel nozzles. The cost of each brass nozzle is okay, since about $3 per nozzle is fine, but the cost of their hardened steel nozzle is comparable to micro Swiss nozzles. For a budget-friendly machine, the price of these nozzles just doesn't seem right. 5. It uses a thin ribbon cable to connect the screen, but the insulation doesn't seem as durable as the traditional ribbon cables found on machines like the Ender 3 or Prusa machines. During testing, I noticed the screen flickering. When I adjusted the cable by pulling or moving it, the flickering stopped. If this keeps happening, I'll need to request a replacement cable from Sovol. 6. The SV06 Ace lacks power loss recovery, which is pretty surprising for a modern 3D printer. Additionally, the motherboard only has 512 megabytes of memory, whereas most Clipper motherboards usually come with a standard 1 gigabyte. While I didn't notice any performance issues during my testing, this could still limit the printer's potential for future software improvements, and I also can't see any huge manufacturing cost savings with this half-gig memory cut. In conclusion, the SV06 Ace is a well-rounded bed slinger that offers good value for its price, kind of like a budget all-you-can-eat buffet. While it may lack the refinement of fine dining, it certainly offers a lot for the price. As a mid-range budget bed slinger, it will inevitably be compared to the BambuLab A1. While both machines deliver good service quality and accuracy, the A1 still has the more polished design, better build quality, and it supports multicolor printing when purchasing the optional AMS Lite. However, the A1's closed system restricts customization options and firmware access. In contrast, the SV06 Ace runs on an open Linux OS with Clipper firmware, providing flexibility for modifications and the installation of additional software of your choice. While the fine details and the overall build quality aren't as good as the A1, the SV06 Ace achieves faster print speeds not only compared to the A1, but also compared to all other bed slingers, and it even surpasses some Core XY machines. The surface quality and accuracy it delivers are better than average, even when printing at high speeds. That's something I didn't expect from a bed slinger at this price point. While my machine had some imperfections, the SV06 Ace could still earn a spot on my recommendation list as the best budget all-rounder bed slinger. Be sure to check out my website for the latest recommendations and my 3D printer price tracker to spot great deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.